inquiry learning. Inquiry learning is not constructivist. It's constructivist referenced, and I talked about that before on the constructivism vid, so I won't belabor the point. It's consistent with the constructivist theory of knowledge. This is a concept that I think is original to me. I don't think I've heard it anywhere else. It's the idea of open-ended versus open-entry constructivism. Inquiry. Basically, there are two possible kinds of inquiry that can happen. One is if you have a scientific concept. If you want the students to learn a scientific concept, then what you actually want is open entry inquiry. You want a wide range of questions at the start, a wide range of perspectives. You want all the misconceptions. You want them to be out there on the table and discussed and so on. But over time, with experiments, with teaching, with learning, you want them to all end up at the same place. You want the students to understand the canonical, correct, accurate, workable, best we currently have scientific concept, because they have to pass an exam, which is the trivial reason, but because it's powerful for explaining experience, which is the real reason. But in teaching science, you do not want to start open and end up with two competing explanations, which the students then take away for the rest of their lives, and one of them is going to be wrong, because the scientific one is the best one we have, so all the others are going to be less than the best one we have. So for scientific concept learning, open entry, closed end, or closed onto a single thing end. You want them to learn the scientific concept. For socio-scientific issues, so for issues like, should we use nuclear power as part of our power mix in Australia? There are a very wide range of possible answers that we could use. There is scientific knowledge that's relevant, so you need to know about half-lives, you need to know about types of reactors, you need to know about safety precautions, and you need to know about nuclear waste, the kinds of waste that are produced, how long it lasts, how it needs to be stored, etc. So there's a bunch of science, but there's also a bunch of economic. Are they economically viable? Are they too expensive? Would they take too long to build to really be useful? There's a bunch of, people won't want it in their backyard. People are scared of it after watching the Chernobyl documentary and seeing the Fukushima coverage and so on. And so on. So you start open, you start wide, and there's a range of valid conclusions to come to, because the answer is not scientific, it's socio-scientific, and people will have different values on different things. So some people will be more worried about the radioactive waste and how long we have to store it. Others will be more worried about, is this a better replacement for coal, for example, because it doesn't produce greenhouse gases? And is it more viable and more reliable day and night, windy, not windy, sunny, not sunny, than renewables? Maybe, maybe not. Maybe renewables plus storage, etc. But you can see what I mean. There's a range of possible valid positions to take. We might disagree about them, but we can't say that they're categorically wrong. They're different because they're different value positions. So for socio-scientific issues, open entry, open-ended. For scientific concepts, open entry down to the correct concept. Is that clear? I hope it's a useful concept, because I hear, unfortunately, sometimes teachers will say, oh, there's no right answers in science. It's all about your own perspective. It's like, no, wrong, bad. There definitely are right answers in science. But on the other hand, you could also, as a teacher, be way too dogmatic and say, no, we definitely should have nuclear and there's no arguments against it. Well, that's also not appropriate. So hopefully that's helpful. Inquiries about questions and who asks the questions and who owns the questions. Do the students come up with the question themselves? Do the students come to own the question and decide that that's something that they want to, that they want to investigate and explore? Or does it always remain the teacher's question that the students are just complying with? Hopefully the students own it in some sense, that the inquiry, that it's their inquiry, that they care about the solution and the ending. When I was talking about planning, about the story arc of a unit plan. So you've got a beginning, a middle, and an end in the unit plan. That's one of the things that can help the students to own the question. Because the beginning and the middle and the end, hopefully, the end might be answers, the beginning and the middle are probably questions. probably things that they want to know about, things that they're inquiring into. In developing a new concept, particularly if the students are developing the concept among themselves in a small group or as individuals working with experiments, they will develop the concept, but they won't necessarily develop scientific language for it. So they might have a push or a pull as a word. So there's a push acting in this direction. They won't necessarily come up with the word force to describe that. So the teacher's role is to help provide them with that scientific language, that literacy of science, so that they understand that there's a term called force, there's a term called mass that's different from weight, those kind of language terms, that they use language carefully and in scientific ways. And as I say, that's not something that they're going to construct for themselves by experiment. That's something that they learn as we teach it to them. Kinds of evidence, I keep hammering this: real world experiments, real world evidence is valuable. Library evidence is important, and in the assessment tasks in the new senior syllabuses, they're asked to do a student experiment, which they have to do real world experiments, create primary data, and they're asked to do a student investigation in which they're asked to go to the literature and get secondary data. So they have to do both of these things to develop their concepts. Inquiry basically can be understood as meaning, oh, well, you know, you're on your own, kids, just go. Just throw you in the deep end, here's some apparatus, figure it out for yourselves. It's clearly not that. Doing good inquiry teaching involves being really actively engaged with the students, their questions, knowing where they're up to, what the pain points are, where they're going, do they own the question, are they on topic, are they off topic, and so on. So you're very, very actively engaged as a teacher in inquiry teaching. We scaffold, we ask the questions, we scaffold them into the skills as well. I think in scientific inquiry processes are complicated and challenging, and doing that properly requires scaffolding and development. You know, the scaffolding is a metaphor around constructivism as well, that you put the scaffolding up outside to allow you to build the building, and then you take the scaffolding away when the building can stand by itself. So we scaffold to support the students as they develop the skills, and then once they have the skills, we take our scaffolding and support away, and they inquire in their own right. So we're developing these skills in collecting, analysing and interpreting data, how to draw a graph. We don't just assume that they'll understand what goes on which axis and how to create a scale and all of that kind of stuff. These are skills that we help them build up. The last piece is managing arousal. It sounds a bit wrong, but it basically is psychological arousal. It's the way in which students are engaging with things. And it goes back to my hand gestures about the zone of proximal development again. If they're not being challenged, if they're down in this zone where they can already do it easily by themselves and not learning anything new, then their arousal will be low because they'll be bored, they will be disengaged because there's no prospect of learning. If they are up here where they can't possibly do it, where they're stuck, lost, have no idea what's going on, they also will be disengaged. So as you're the teacher, you're wandering around the different groups doing their activities, and you're listening in. You know whether that group has stopped because it's too hard and they're stuck, and you can give them some information or ask a question that directs them to some information, or give them a prod and a nudge in some other way. And you can know whether that group's off topic because they're bored and it was too easy, and you can challenge them with harder questions and so on. So you're managing that all the time. Some level of frustration. So it's like playing a game on the computer. If it's really super easy and you're just grinding, doing the same easy thing over and over again, it's really boring. If you're doing an impossible battle over and over again, it's equally boring, or you rage quit and you've had enough. It's in that zone of just being challenged to build your skills that it's actually fun to play. And it's the same in school, that it's fun to play when you're in that zone. Okay, that's been a quick run through of conceptual change theory and inquiry learning. It is a longish day, and there are two more pieces, explanation, teacher explanation, and teacher expertise, and they'll be pretty quick, and I'll talk about those in the next video. See you shortly.